Jennifer is a PhD candidate in land and atmospheric science at the University of Minnesota. And 2 years ago, I read about her research in an article titled, "What Do Gardens Bring to Urban Ecosystems?" And the article was very interesting to me, so I asked her to talk about her research and how to apply this information to home and community gardens. Jennifer tells me she doesn't know when it's going to rain, so she doesn't know a whole lot about the atmospheric part of the science, but she knows a lot about community gardens. If you have questions while Jennifer is talking, please put them in the chat and we will get to as many as we have time for at the end of her talk. And please make sure your mic is muted during her talk. And welcome, Jennifer. Thanks for coming in for your gardens to talk to us.
Thanks so much for that great introduction. And yes, like I'm sure many of you, this is my favorite time of year, being able to be out in the gardens. I, in addition to being a PhD student, I also started and helped run a community garden in the Southeast Como neighborhood of Minneapolis. So I don't just study it, I do it. And I'm also an activist working for policy change. So my days are busy, but I love, I was a 13-year 4-H'er in Carver County. And so of course got to interact with master gardeners throughout that entire time. So I was so delighted when you invited me to come. So like Sue said, I'm a PhD candidate at the University of Minnesota. And I identify as a political agroecologist, which is a really fancy way to say that I study the relationships between people, social and political systems, and the ecosystems that we live in, especially soil, because I'm in a soil department. So for my graduate research, I work with urban farmers and gardeners to explore how their practices impact the environment in their neighborhood and the people who live there. So growing food in cities has a long history that's like way beyond the scope of this presentation. Here we see it in container gardens on balconies and farms within the city, like growing lots in this picture. Growers, organizers, residents, and researchers see that urban agriculture impacts human and more than human communities, including animals like squirrels or cats, insects and pollinators, trees, and fungal networks. A lot of research and policy programs have focused on the amount of food that urban farms and gardens can grow, but we don't have a lot of data to explore how urban food cultivation supports environmental relationships, which could include things like whether it increases or decreases soil carbon, how it changes how water is stored in the soil or on the landscape, and so many more things. And that's where my work and my passion comes in. And it involves the people, myself, the growers I work with, and the broader network of folks involved with urban agriculture. The place. My research project is rooted at farms and gardens in 4 neighborhoods in Minneapolis and St. Paul. And the growers and researchers designed the project and objectives and methods with those places and their practices in mind. And then there is the impact we have. So synthesizing, we'll talk about synthesizing the results we've seen to tell us stories about the diverse impacts of urban agriculture. So let's start with people first, starting with me. I figured sharing the story of me in relation to food will give you a bit more info about the experiences and perspective I'm coming from. And to start with, my family farmed in Eden Prairie for over 100 years. This picture is from our last season of farming. I was young, as you can see. I was either 3 or 4. Where my older brother's hand-me-downs and a rock and a great early 90s bowl cut. And I, as a kid, I grew up learning the stories of my great-grandparents, my parents. They sold at farmers markets, to grocery stores, and to wholesalers. On the upper left is my great-grandma at a farmer's market and me hanging out with my great grandpa in the lower right. And from those stories, I knew that my great grandfather especially was dedicated to always exploring farming practices that minimized his chemical use, kept soil on his farm, and provided a learning space for the community. He was on the school board and on city council committees, and I always understood that growing food was about being in community. So, like I said, we stopped farming after my great grandfather passed away, in part because it wasn't the life my parents wanted to lead, and in part because suburban development made it too difficult. I spent a lot of years feeling very connected to the place I grew up, but really disconnected from how to be in relationship with it. But as an undergrad at the U of M, I started to seek out that relationship in the food community. So finding urban agriculture, particularly the community gardens and container gardening projects in my neighborhood, was a revelation. And suddenly pieces started to click into place about how I could honor the legacy of being in relationship with land and people that I inherited from my family. I started coordinating a container gardening program in my neighborhood, which was 75% renters, which meant that container gardens were one of the only ways that gardening was really accessible to people because they could move it with them, it could fit on a balcony, and it was like a low bar entry into gardening for people who had no experience growing food. And what I loved about it was the way it challenged me. Like, I love growing food, but like that was always part of my life. And this project challenged me because we were working on a super small budget. So we're trying to reuse products like plastic bottles and these barrels, these food grade barrels that we got from a company in the neighborhood. I was learning so much about plant varieties I'd never heard of. That's when I discovered the fairy tale eggplant, because it's a kind of a dwarf variety that likes growing in small spaces and produces a lot. I was finding all these varieties to grow in containers that I hadn't known about before. And I was building succession planting plans, which was definitely not something that had been in my experience at that point. And I wasn't doing it alone either. I said been involved with Master Gardeners through 4-H for 13 years, but I had a mentor, Stephanie Hankerson, who's a Master Gardener, who was my internship supervisor. And she gave me so much ownership in coordinating and designing the Grow Barrel program. Her curiosity and innovative spirit were so inspiring. And we had endless conversations wondering about how the plastics impacted the soil, what alternatives there might be to peat moss in the container soil mix, since that's a limited resource, how relationships between different plants were impacting the yield, and more. We had questions every day, and I knew I wanted to eventually explore these quirky, beautiful urban ag systems in my graduate work because they are endlessly fascinating. So I started as this kid with a clippers bigger than the same size as me, and I'm like still using those clippers in my graduate work. And I'm here 30 years after I was farming as a kid, 10 years after Stephanie's really important mentorship, showing really the impacts y'all as Master Gardeners can have. And I'm using those trimmers and the skills I've learned over those years in my work studying urban agriculture in Minneapolis and St. Paul. Now, the group I work with for my research, we call ourselves the Collard Crew because it was sort of a gifted name to us from Stephanie, actually, who continues to be really involved in the neighborhoods that I'm working in as a master gardener and garden educator. And so we are the Collard Crew because we grow collards, and we have 4 different growers and 5 faculty members and like an endless crew of students who we love dearly. And specifically, I've been working with those 4 partners, like I said, Growing Lots, Urban Farm and Garden Alliance, Wait House, and Frogtown Farm. And they all vary in structures, missions, and growing practices. The neighborhoods and communities they're embedded in are really different as well. The Minneapolis farms are located in a neighborhood whose residents are predominantly members of indigenous nations or are refugees from Central and South America and East Africa. And the St. Paul farms are neighborhoods whose residents identify as Hmong or Black and are also led by growers from those communities. But even though those four are the people who I've worked most closely with, we have like deep roots. And by we, I mean my advisor and my research partners and my community partners. We have deep roots and connections to a lot of urban farmers and gardeners, a lot of educators, a lot of extension folks, a lot of other community organizations, and we're accountable to those folks too, which is why I also take every opportunity I can to share about our project, because it helps get the word out and share the results even as they're coming in and we're trying to understand them still in a way that makes sure that this is transparent and iterative and continues to honor the relationships we're in with each other. With that, that is the people. And I'm going to take a quick drink of water. So, where's the place we're embedded in? Urban agriculture in the Twin Cities usually refers to urban farms run by nonprofits or as farm businesses, to community gardens run by groups of people, or to home gardens that are growing food in the soil or in raised beds. Now, of course, urban agriculture can also include things like hydroponics or aquaponics, or rooftop gardens, but we don't have a lot of those in the Twin Cities, and it hasn't been the focus of my work. This map in particular shows the community gardens as green dots in Minneapolis and St. Paul in 2015, which was the last time a census of gardens was done for both cities by Gardening Matters. And at the time, there were nearly 400. We have a bit more data for Minneapolis, where we know there are 93 acres of land in urban agriculture, and that includes farms, community gardens, and home gardens. Home gardens are about 30 acres, so about a third. Community gardens are 2/3. And then there's a handful of these farms. And I want to come back, now that we have a kind of a picture of what urban ag is in the Twin Cities, to this idea that urban agriculture has a lot of different impacts on the neighborhoods and the places where it's done. But we don't have necessarily a lot of information beyond for research about what those impacts are beyond yield. And that was becoming kind of a challenge for the 4 growers I work with. They were sharing their observations and experiences with policymakers and funders, and the responses they were hearing were often calling for more quantitative data. And so that's where this research collaboration came in. Together, we came up with the objective to collaboratively evaluate the extent to which urban agriculture practices impact ecosystem service provision. And we're going to dive into that, the different pieces of that. So first, let's talk a little bit about what I mean by practices. For us, that meant 3 different treatments. The first was adding compost to the soil. We use municipal compost. That's produced at the mulch store from the various organics recycling programs in the metro area. So that means if you've used organics recycling in the last 3 years, then maybe some carbon or phosphorus from your lunch ended up growing some collards. In addition to that, each of our 4 partners chose a grower's best practice that they were interested in learning more about. And those were wide-ranging. Brewer's mash is the spent grain from brewing beer, and it is very easy for growers in Minneapolis and St. Paul to obtain from local breweries, and it's an especially important amendment for White House. Growing lots had a rural parcel of land that they used to grow squash, where they were just drowning in comfrey. So they wanted to try mulching the vegetable beds with the wilted comfrey, which some permaculture publications have really advocated for, and I, in fact, 2 weeks ago, found a University of Minnesota report out of Rosemont, really like being a booster for comfrey as a crop from the mid 1980s. So that was a fun find. Frogtown Farm was using clover between rows of vegetables, but knew that this intercropping practice could tie up nutrients. So they wanted to know a little bit more. Finally, the Urban Farm and Garden Alliance most often used torque boxes and raised beds, and they wanted to know how that compared to their in-soil growing practices. They also tried out alfalfa tea, which is alfalfa seeds sprouted and fermented in water for several days, which really smells bad. But the idea is that the fermentation process makes some of those organics a little easier for microbes to digest and then for plants to take up. So finally, we compared those practices, the compost, the grower's best, and grower's best to a control, which we did nothing to, and to nearby grass areas. Each partner hosted replicated plots. So that means they had 3 plots amended with compost, 3 with grower's best, and 3 controls, and 3 grass plots. Now, agriculture research is, to be frank, utter chaos. Like, if the weather isn't out to get you, which we can absolutely see right now, that's the rabbits stealing whole plants or heavy equipment driving over your plots because a tree fell during a storm and they need to clean it up. Total chaos, but in a fun way. I really enjoyed it. Our small replicated experiments had a lot of external factors we couldn't control, which is why we added 2 additional components. First, we also set up some observational plots where farmers did their usual thing. We just took some measurements, and that gave us an idea of kind of the background variability of what the breadth of values we might see over urban agriculture. Secondly, our on-farm experiment was designed in conjunction with an off-farm study, which meant it was done in research fields at the University of St. Thomas, led by Dr. Chip Smallbear. And in those, he had room, as you can see on the right, he had room for more control over his experimental space because since it was on a university campus, him and his crew were managing the whole thing. And he was also able to study 4 crops and 6 treatments. And I share this broader experimental design to emphasize that community science requires many strategies. So even though I'm going to spend the rest of the presentation really focusing on the on-farm project, because it was what I was most involved in, it's certainly just one piece of the puzzle. So, like I said, that was the urban farm agriculture practices part of our objective. And now we'll move on to the ecosystem services those practices provide. And I've kind of mushed together explaining more about what ecosystem services are, alongside sharing some of our preliminary results. So ecosystem services are ways that ecosystems support our lives. There are 4 categories of services: provisioning, regulating, supporting, and cultural. It's handy because, like I said, for a long time, agricultural scientists have focused a lot on yield, but not necessarily looking at how prioritizing yield impacts other types of services, like soil quality or nutrient cycling. And we see more and more of that research happening over the past 30 years at least, and more, probably more. I'm probably doing the math wrong. And so ecosystem services helps us understand that breadth. They aren't perfect though. Ecosystem services center humans rather than necessarily approaching ecosystem services ecosystem services center humans, and the benefits we get from ecosystems without really considering them, entities of their own that can and do function without humans. And ecosystem services are often used to monetize aspects of the environment, which can never fully capture the importance of environmental processes that help sustain so many kinds of life. But ecosystem services are a legible framework for growers, researchers, and policymakers to talk about the diverse impacts of urban agriculture. And that's what we needed in a framework for this project. All told, we measured 20 different metrics to explore many ecological processes. And I'm only going to go through a couple of those with you today. And before I do that, this is disclaimer. These are preliminary results. I'm presenting data from 2018 and 2019 because we're actually finally just getting the final bits of 2020 data in, thanks to our work slowed down quite a bit as a result of pandemic precautions. And so preliminary data ahead. The stories we're seeing may change. They'll probably change, in fact. But it's exciting to start seeing what some of our measurements are telling us. So even though I'm like, my common refrain has been, let's consider things beyond yield, I'm going to start with yield because we are growing food, and that is part of the point. And in some, and a lot of the times, it's a main motivator. So in our project, we were able to grow 1,800 pounds of collards in 2018 and 2019 across our plots that went straight back into the communities where they were grown, either in CSA boxes or to food shelves, or just like neighbors sharing with each other. I dropped collards off at a funeral home one day to be put into a funeral lunch. And then later that day, I cooked them, I took some of them to a friend whose aunties are from Libya, and they were going to cook them into the traditional meals. So they ended up everywhere. And so let's look at some of the trends behind that harvest. We're going to have fun with box plots for the next, for several of these different ecosystem service metrics. And along the bottom will always be the treatment, and each section represents a different site. And so you see Frogtown Farm, Growing Lots, Pilgrim Baptist, and Wait House along the top. And here we show the kilograms of yield harvested per meters squared. 2018 is in green, 2019 is in purple. So as you can see here, our 2019 yields were lower than 2018 in general, almost across the board, likely because it was colder and rainier, though we're trying to see if that's statistically significant. And in a lot of ways, that's not what we want to see, like as growers or, as people who are stewarding an environment. We want to see that yield either kind of stays stable or maybe increases a little as we get better at what we do. But that's not what we see here. But that doesn't mean that it's bad necessarily. It could, like I said, be a quirk of the year, quirk of the weather. What is interesting is if we look here at Wait House, at Brewer's Mash, and we see that despite the fact that yield was lower in 2019 for the rest of the sites and treatments, it was about the same for Brewer's Mash. And that's interesting. That makes me wonder if Brewer's Mash as a soil amendment has like longer term nutrient availability, or if it's providing other sorts of resilience against these weather shocks. Another thing to notice is that compost treatments always had, in general, had like less of a yield loss between the years as compared to the control or some of the other observation, some of the other growers' best practices, which again could indicate that compost is providing those nutrients and some long-term nutrients that protect against or some moisture holding capacity that protects against things like rainy, wet conditions or other things that we might not expect. That resilience that's really important as the weather gets more unpredictable with climate change. Let me just clear all drawings. If I don't clear the drawings before I move to the next slide, those boxes just stay with it. So what does that mean in a broader context? Like, yes, yield decreased from 2018 to 2019. There's possible reasons why. And there were cool trends that indicated maybe some practices that could protect against yield loss. But ultimately, both years, we harvested plenty of collards from our sites to feed the communities we were embedded in for events, for celebrations, for periods of grief. And that's what in a lot of ways matters. As one of our growers said to me this year, when we were meeting, she said that, you know, when they harvest for their dinner, they don't go out and measure a pound of greens or a pound of beans. They take what they need. And if we can grow and harvest what we need, that's what matters. So I just talked about a provisioning service, yield. We also measured plant quality. I didn't include that data isn't included here because it's still in progress. So let's move to regulating services. Now, regulating services moderate natural processes. So this means like water, you know, water storage, water infiltration, water quality. It's all mediating how nutrients are cycled through the environment because nutrients flow in water. Or carbon storage. Carbon storage is a regulating service because it carbon holds nutrients for us. And we'll talk about that more in a bit. First, we're going to talk about water infiltration, which is how fast water is absorbed by the soil. And if we put that in context, that means my friend in grad school often describes this as like, the goal is to keep the rain where it falls. So if the rain falls on your garden, we want to keep it there rather than running off. We don't want it to be flooding. We want it to be soaking into the soil where it can do things like provide water to the plant and to all the like microbial processes that are happening. And so one of the strongest trends that we saw in urban agriculture compared to grass areas was a much higher water infiltration rate in the top 1 foot of soil. So that is, forgot to turn the draw tool back on. So that is this in red. And we can see that urban agriculture is about averaging at being able to absorb 2.5 inches of rain per hour, which is a downpour. Some sites could absorb 7 inches of rain per hour or more, as you can see by those outlier dots as it goes up the screen. That is astounding. And so, whereas grass is maybe more towards the 1 inch per hour, which is still respectable. But when we've got these higher infiltration rates in that first foot of soil, it means that we're really seeing less flooding, less runoff, and more likelihood that that water is going to be used to support the garden. And why is that important? Like we were talking about, if you're here before we got started officially, we were talking about the rain and when is rain going to come, because we are all feeling this drought. And the answer is rain is going to come likely in mega rain events. I don't know. I mean, obviously, I'm not in atmospheric science and also not a meteorologist. So I don't know when it's going to come this year, but I know from what atmospheric scientists in my department have told me, like Tracy Twine, that we're going to see more and more mega rain events and these longer periods of drought between them. And so if our soils can absorb those mega rain events, it's really making sure that we make the most of it in our growing areas. It's keeping it out of our streets and stormwater drains. And then that means it's keeping it out of, it's keeping runoff from soil, from leaves, from other pollutants that are on roads. It's keeping it off or out of our stormwater and out of our lakes and rivers. And that is a really cool benefit that we're seeing from urban agriculture. So, like I said, we're going to talk about another regulating service, carbon storage. Now, carbon gets stored in soil in a lot of different ways. And we generally think of it in these three pools that you may have. I know there's a soil module in the Master Gardener training program because I subbed in one time. And this was a big thing that we cover, is that soil organic carbon is in living things, in dead things, and in very dead things. So living things are like microbes and roots and mycorrhizal fungi networks. Dead things are like crop residues and dead roots and dead microbes. And the very dead things are soil humus, which are like super intricate networks of carbon that really it's like this web that makes it so hard for anything to get at the carbon and other nutrients that are stored inside of it, which makes them available over the long term, like over 500 years long term. And so when I measured soil organic carbon for this project, I looked at the total across these three pools. I didn't look at, I did look at individual pools, but the number I'm going to share, the info I'm going to share with you today is just the total. And so we're back to this blocks plot situation. The treatments are still on the bottom. Note that the treatments are color coded as well. Green for compost, purple for control, orange for grower's choice, and teal for observation plots, and sort of the off green for turf grass, because I wasn't really sure what to color that. So what we found was that carbon stocks vary quite a bit, and carbon stocks are a little different than organic matter. I should explain that. Organic matter is the percent of carbon in a certain volume, or percent of carbon in a certain volume of soil, but carbon stocks account for how much soil is in that same volume. So there can be different amounts if we imagine like how much soil is in a cup. There can be different amounts based on how fluffy it is, or how much clay is in it, or how much like bark is in it. Like it can have different volumes of soil in that amounts of soil in that same volume. And so carbon stocks take that into account, whereas organic matter doesn't. So that's why I like talking about carbon stocks. It sort of equalizes it across and standardizes it across sites. Well, it's the same thing. We're still talking about carbon in the soil, and we generally want more because it helps provide nutrients over the long term. So we can explain some of the variation we're seeing in carbon stocks with things we know about the sites. So for example, the observation area, which I mislabeled as comfrey mulch. So the observation area at growing lots, it's not comfrey mulch, it's observation here. This has been under cultivation longer than the sites where we were growing in the replicated plots. And so they've been adding compost for longer, they've been adding manure for longer, they've been adding leaves for, like, they've just been adding carbon. So we're not surprised that that just has more carbon than where they've been growing for a shorter period of time. The growers best at Weight House, the brewer's mash, it's this one. This was me thinking I was smart, like adding in the labels for specific growers' best practices and then choosing the wrong one, the wrong label to change. So we see that the growers' best, the brewer's mash at Weight House, also has higher carbon. And we're interested because maybe it's like the fermentation process that it goes through at the brewery makes that carbon more accessible to be integrated into the soil. We don't know. That is something for more explanation. And we're interested to see what happened in 2020 now that we have that data coming in. So that is sort of like what we're seeing. We're generally seeing variable amounts of carbon stocks as a result of urban ag practices. We're seeing some cool trends in how time relates to it, how carbon builds up over time, and how specific types of amendments may help build even more carbon, soil carbon. Saying that, we're seeing, like, this is really high soil carbon. Like, we're talking, usually seeing half of this low amount. So half of this 7.5 kilograms per meter squared, usually half of that is considered like awesome. So we're seeing good carbon across the board. And in the broader scheme of things, like, that's what we're trying to do. Like, when we are adding compost to the soil, we are in relationship with the soil, saying, like, these are, when we're adding compost, when we're adding brewer's mash, when we're adding these amendments, we're saying, like, this is our investment in long-term soil fertility. This is our investment in long-term nutrient availability. This is our investment in supporting lots of kind of life. I added this picture on the right because this is like a soil fungus, interspersed with wood chips, interspersed with earthworm pores, interspersed with, like, all the microbial communities we can't see through the naked eye. And as gardeners and farmers, we're facilitating that, and we're participating in it, and that's really cool. So that was regulating services. I've talked about water infiltration and carbon storage. We also measured water quality and water storage, and those results will come in the future. The next thing we're going to do is talk about supporting services, and supporting services are processes necessary to support other services. Like, they have to happen in order for other things to happen. So for an example is, we have to have nutrient cycling, like phosphorus cycling, in order for plants to grow, and in order for microbes to thrive. And in this picture, I show how we collected the water leachate, where we calculated how much phosphorus was in the water that got below the root zones. It was a super fancy system of using a Nalgene bottle with a funnel and a tube going down to it. We buried the Nalgene bottle 2 feet below the surface and brought the tube up to the top of the soil, where we used syringes to pull out the water. You can do science on a budget of like $5 a bottle. And so why is phosphorus cycling important? Like I said, plants need it to grow. And a lot of times, since phosphorus doesn't move very much in the soil, things like fungi are really important to how plants get a hold of phosphorus, because fungi have these super extensive networks of hyphae that help bring that phosphorus closer to the plant roots so they can access it. But too much phosphorus can contribute to pollution, especially once it reaches the waterways. It can cause these algal blooms. So on working on that balance, we want to see phosphorus remaining fairly stable, hopefully. And for example, at Frogtown Farm, we see that. We see it stable across all of the treatments and the observation. Reminder, the observation is in blue and I just mislabeled them. But at other sites, we see that, for example, at growing lots, phosphorus has been increasing. And as a result of this preliminary data, in fact, they changed how they did nutrient amendments. So we are seeing changes to their, while those changes aren't reflected in our experimental plots, we saw changes in phosphorus levels reflected in their broader farm. And similarly, as always, the White House has a quirky result. Their observation plots were brand new, like brand new, that we helped build those beds. And their phosphorus was lower, which shows us that phosphorus accumulation in soil is also related to time under cultivation. And another important thing is when we compared soil phosphorus to the amount of phosphorus in the water that made it below the rooting zone, there was this point at which leaching increased. And so when soil phosphorus got to be above 30 to 40 parts per million, which is consistent with the U of M extension recommendations, when it got above 30 to 40 parts per million, we started seeing more phosphorus in the water that leached below the rooting zone. And so this shows the importance of really considering how we're using nutrients like fertilizer or compost in growing food. And this is, but we also have to balance that with like plants need phosphorus. This is, many of these leaves are showing signs of phosphorus deficiency. Leaves will turn purple. And so it's a balancing act, and it's a constant, like for growers, our hope is that our final research can help provide some more recommendations for this. But it's just a constant experimentation as growers, learning what that balance is. So that's where master gardeners have a role in helping people navigate these really complex decisions that they're making. And so I'm almost done. We're just going to talk about one more supporting metric, which is insect biodiversity. And I'll be the first to say that I'm not an entomologist, but I have become a functional entomologist because of this project. And so insect biodiversity, we measured through sticky cards, which was that yellow paper, bugs hit it and stick to it, and pitfall traps, which it had some liquid in it that they fell into. And we were able to ID them later. So we were looking at functional groups for insects. So pests eat the things that we're trying to grow. I see you Japanese beetles and I struggle. We have pollinators. So they're the ones that are moving the plant's genetic material. We've got predators who are preying on other insects. We've got parasites that are using other insects as hosts. And the things that we call beneficial insects are usually pollinators, predators, and parasitoids. And so thank you to Mary Rogers and to Naomi Candelaria and Yashira for really working with this data. But we generally saw across the sites that there were more pests than beneficial insects. But of the beneficials, we saw most of them were wasps and pirate bugs. And then thrips and aphids were the most prevalent pests. And so this is useful to keep in mind as we have so much more to dig into with this data. But it's useful to keep in mind because what we saw growers asking for is systemic ways to manage pests rather than with avoiding pesticides, essentially. And so a systemic way to manage pests, for example, is what you see growing on this garden shed. This is my community garden. And we grow grapevines on our shed, in part because grapes, yummy, tasty. And also, added benefit that we didn't expect was that they are a trap crop for Japanese beetles. So that means that our beans are usually fine. The Japanese beetles are so delighted with the grapevines and the grape leaves that they never even bother with our green beans. So we're able to find a systemic solution to the pest that we can't do anything about. Otherwise, like, it's very hard to manage for Japanese beetles, as I'm sure many on this Zoom know. And our grapevines are so dense that we don't really see a meaningful loss in production there. So that's can be handy to think about as you're working with gardeners about, like, what are the relationships between insects that we can help facilitate as growers. So in summary, I shared supporting services which help make sure that other processes run, phosphorus cycling, insect biodiversity, and those are what I shared today. We also did work with nitrogen cycling and soil quality that, again, will be coming out in the future. This is all the things we measured. It's not important to, like, read and take in and absorb all of it. I most days have trouble looking at it, not feeling overwhelmed. But it's a reminder that a lot of things are operating in the gardens and the farms that we steward, and it's really where those intersect that we see the impacts that we have. And so I'm going to end with this diagram that shows the services provided by Urban Ag. I'm going to try and give a little bit of an orientation to it because I know it's kind of a dense one. So this outer ring represents the highest value we saw for a metric. And this middle part is like 0, like we didn't see that metric at all. And each of these triangles represents a different thing that we measured. And some of the grayed out ones, like microbial community, we have data on, but I haven't analyzed it yet. And so what we see here is that urban food production sites show increased soil carbon, yield, and water infiltration. And generally phosphorus is retained. So as much as I was like, we need to be cautious about phosphorus, like, generally it's retained. It's like, we are generally doing a good job at striking that balance. And what's cool is that this is a little different than grass, which, apologies, my those grayed out triangles got weirdly moved in a copy probably. So the big difference that we see, of course, is that urban agriculture provides yield and grass does not. But we also see a little bit more soil carbon being stored when compared to grass. We're seeing higher water infiltration in that first foot of soil compared to grass. We're seeing higher soil phosphorus and still, like, okay soil phosphorus retention. So we're seeing some added benefits compared to land that's in grass. But even within urban agriculture, we're seeing, like, vastly different suites of ecosystem services. So, we saw at Frogtown Farm, we saw the highest soil carbon storage of all 4 sites, but then some of the lower water infiltration rates. And, the important thing to think of looking at both these diagrams is they're not really right or wrong. They're just reflecting different practices and priorities at different farms. And that is a reality that we face in home gardens, community gardens, and farms, is that each person has different goals, different values, different knowledge, different practices that they're bringing. And so they're going to have a different suite of impacts. And that's really cool. It's really complicated, but it's really cool. And so as we, like, continue along this journey of learning what the breadth of impacts we can have, it's important to stay learning together. So I'm really excited to answer any questions you have, and thank you again for having me.
Thank you, Jennifer. I don't see any questions in the chat, but I have a question. Do brewers sell their brewer's mash?
So for the most part, brewers need to pay to dispose of their brewer's mash. And so I've generally found that when I give the brewery a call, they are very excited to just let me come and scoop it into my truck from the dumpster where they put it out back. So I haven't heard of them selling it. I've heard of them being very pleased that I'm taking it off their hands.
Okay. Good. Anybody else have a question?
I'd like to ask a question. I was trying to type it. This is Linda. In the first slide that you showed for infiltration of water, you noted that there was significantly more water infiltration in the grassy sections. That seems surprising to me.
Let me pull up that slide again, because that's a really good question. Thank you, Linda.
There.
So where we see urban agriculture with significantly higher water infiltration is this first 0 to 1 foot of soil. So that's generally the rooting zone,
Right.
and what we're interacting with most. Grass, you're right, still does have this larger range of infiltration rates, and some of those being higher in the 1 to 2 feet. Sorry for the mislabel. This is 1 to 2 feet, but they actually aren't significantly different. If the infiltration rate for urban agriculture in blue is within and very similar to the mean infiltration rate we see in grass at that level. So they're almost the same, even though that grass infiltration rate looks higher for that mid depth of 1 to 2 feet.
Well, and also at the 2+ feet level.
Yep.
And I thought,
mm-hmm.
Is that not statistically significant? Because, the whole idea of retaining the groundwater seems like a goal that you mentioned is important.
Right. Yeah, it's not a statistically significant difference. So what that means is that even though we're seeing differences in either the range or the minimum and maximum values, ultimately there's not enough difference for us to say grass and urban agriculture are any different for 1 to 2 feet and 2+ feet. So once that gets past, the water goes into that first foot a lot faster, and then it is still infiltrating at the same rates for those lower levels.
Thank you.
There are 2 more questions here. Tommy asks, where is your biggest need for Master Gardener volunteers?
Oh man, I have so many ideas. So the first thing that comes to my brain is that Master Gardeners y'all are some of the richest sources of questions. You get to see the weird up close, and you are really good at observing the quirky things that are going on or seeing differences as they come up. And so I love, and I know this is also true for other researchers and grad students and faculty members, we love being in relationship with Master Gardeners because you are at the front lines of seeing what people are doing and what they're experiencing. And that is really good grounds for research collaborations, to look into what might be causing the weird things you're seeing. And then 2 is that, now I theoretically have all this data that still feels really overwhelming most days. And then, so where I'm at right now is trying to put it in forms where I can share it with people. And the 2 next steps are really validating that does this reflect what you're seeing in your own experiences, or is it different? And should we be like looking into those differences a little bit more? And two, are there ways that we can get this information out to gardeners and out to folks working who are growing in their yards or in community gardens, in ways that match the communities you're working in, that match how they like to communicate, that match how they like to learn. And that's why I see master gardeners being so important, because you have that expertise, because I can't be in every like community all over the state. That would be exhausting, and just like not authentic, but y'all are. So going forward, like figuring out what that looks like to share this information and to learn together is really important.
One more question, Jennifer. Paul asks, how do you think the collard crop impacted your results? Could it have been different if you grew tomatoes, carrots, squash, and other things that are common in urban gardens?
So I'm sure that the crop impacted things. For us, collards are for the neighborhoods we're working in, collards are really common. It's a very so the neighborhoods I worked in were Rondo, which is a historically Black neighborhood, in St. Paul, Frogtown, which is a lot of refugees and immigrants, and then the Central and Seward neighborhoods in Minneapolis, which are some of the most diverse neighborhoods in the state of Minnesota. And so like a rich variety of greens I had never heard of before this project. Collards I had heard of, but like I came across so many greens are grown in the gardens in these neighborhoods. So this is probably one of the most representative crops we could grow for the neighborhoods we were working in. It was a little easier for us. Brassicas are very forgiving in terms of care. Like we could have a couple weeks of drought and they'd like bounce right back when the rain came. Squash borers can decimate a whole crop, and we generally didn't see pests taking out whole crops. The Swede midge gave us a run for our money. The Swede midge is a new insect that we're seeing in Minneapolis, St. Paul first, though it will likely spread to the rest of the state of Minnesota because of our increasing temperatures. And Swede midge chomps on those growing points. So we did experience some crop loss due to Swede midge that we wouldn't have likely experienced if we were growing tomatoes or something else. Chip at St. Thomas was growing tomatoes, peppers, carrots, and collards. And so we are able to kind of like mush our results together eventually to see like, was there a year where collards really sucked? Whereas like tomatoes were just rocking the world. So we're excited to see how those different trends related to each other as kind of a way to protect against that.
Let's take one more question. Marjorie asked, how would you use comfrey as a mulch? Just put the pulled up plants on the ground?
So that's what we did. They pulled up the plants at their rural site. They let them wilt a little in the truck as they came in to the city, and then we just placed them on top. Comfrey decomposes super fast, like really, really fast. So it was generally like we put it on in July, and generally by the time we were wrapping up for the year in November, most of it, except maybe the stalks, had completely decomposed. So it provided that protection when we most needed it to keep moisture in the soil in those hot months of July and August. And then it was starting to contribute to the nutrients, soil, carbon, and other nutrient cycling later in the year. You could also grind it up. You could also put in your compost pile beforehand and then use compost as mulch. All of those would work. You can also eat comfrey, and it's a medicinal plant.
Okay, we're running out of time, but we have two more good questions that I'm just going to ask. One, MB wants to know, the brewer's mash is used for compost in the garden. Is this something we could sell at our plant sale?
Oh, I don't know. This is a true good question. I think that would have to be like, you'd have to work that out with like, if you homebrew, I assume that that would be okay under cottage food laws. If you were getting it from a brewery, you'd probably just want to have that conversation with the brewery about whether you could package it and sell it. The one caveat I'll say is we mixed our brewer's mash 50-50 with compost because we were putting it on hot. Like I was literally in waders in the dumpster because it was so hot and so fresh from the fermentation process, like literally temperature hot. So we mixed it with compost. But if it sits around for a bit, then you don't have to worry about that. And you can just like either put it on as mulch or you can integrate it into the soil.
Okay, and one more. Can you spell the name of the new pest? Insect?
Oh, yeah. It's so Swede, SWEDE. Awkwardly, like, I don't know why we have to call it for like this Sweden, but like Swede. And then midge, MIDGE. U of M Extension has some information on it. The kind of the characteristics you'd be looking for any brassicas is when the like leaves at the center start twisting in on themselves and curling in on themselves. That's what Swede midge damage looks like. And I've noticed that broccoli, cauliflower, and Brussels sprouts are more susceptible to them than are kale, collards, and mustard greens. I don't know why.
Okay, thank you, Jennifer.